Hi there and welcome back. Today we're going to be working with dividing fractions by other fractions. This is Miss Richtfelder and we're going to be working on textbook page 318 through 320. So you want to make sure that you have your textbook out now. You're also going to be working on standard 6.ns.1, so that's what the focus of this lesson is about. Please be sure that you have your colored pencils ready if you want to underline things as I underline them, circle them, things like that. All of your work should be done in pencil that you're doing when you're working through the problems. Make sure that you're in a pretty quiet location, or at least that you have headphones on, and make sure that you're actually listening to the video. So you want to listen to what I'm saying, think about it, and then pause to write it down in your textbook. Let's go ahead and get started. On this first page here, you'll see textbook page 318. You can see also that I have a little note reminder that says, remember, if I write it on the screen, you write it in your textbook in relatively the same place. These notes do not go in the composition book. So if I write on the borders, or if I write, write on the model, then you should write the exact same thing. All right, let's start on the first page. So it says that this is the key concept. So you want to go ahead and circle key concept. And it says, to divide by a fraction, you want to multiply by its reciprocal. So let's just do a very, very quick review of what a reciprocal is. Remember, a reciprocal is a number that when you multiply it by another number, it makes 1. So for instance, if I was asking you for the reciprocal of 4/5, that reciprocal would be, hold on one second, would be 5/4. And the justification is showing me that 4/5, it's showing me that 4/5 times 5/4 will equal 4 times 5 is 20, 5 times 4 is 20, and all of that equals 1. So this is just how you justify it. This is not, because I see some kids still giving me answers of 1 for the reciprocal, and that's not correct. The reciprocal is actually the number flipped or inverted. So just a quick review on reciprocal. And now we're jumping right into example 1. For example 1, it says to find 1/2 divided by 1/3. Now we're going to first show this example through modeling. This is method 1. Now remember, this is actually what the standard calls for. The standard calls for you being able to match a story or a problem with a model. You being able to divide fractions by using models. So let's go ahead and see how we're going to do that. Now the first thing you want to notice is that this is a little different than when we were dividing whole numbers by fractions. So we're dividing fractions by fractions. So we want to start, the one thing that's mainly different is that we want to make sure that we draw a whole unit. So even though we're starting with this 1/2, we actually want to make sure that we draw a whole unit. So what I mean by that is, notice right here that they drew a whole even though our fraction is a half. So you want to start by drawing your whole, and then you're going to divide it into 2. So that denominator in the first part is what tells you how many slices you need. So as you can see, I have a note here off to the right that says the 1/2, that 2, is what says cut it into 2 pieces. Now they have a bar just below it that's telling you we're going to divide it into thirds. But where most people make the mistake is that they start to divide the half into thirds. But that's not what we're dividing. What we need to find out is 1/2 divided by 1/3 of the whole. So now we want to make sure that we're looking at our whole again. So I'm going to outline this in a different color. So now we're looking at the whole. And then as you can see here, just go ahead and pay attention right now to my purple lines. So as you can see, we've now taken the whole and we've separated it into thirds. So we have 1/3, 1/3, and 1/3, which makes our whole. So now when we're dividing 1/2 divided by 1/3, now we need to essentially forget about this piece right here, because remember, we didn't have a whole to start with. We only had a half. So now we're only going to be looking at the part I'm going to box in black. So now we're looking at just this part right here. See where that dark line is? That's where we're looking. So now we have, how many whole 1/3 pieces do we have? So this 1/3 piece right here, that's one whole third piece. So in our answer, we have a 1 for sure. Do we have another whole 1/3 piece? We don't, because see, this one whole third piece isn't part of our problem. And then this isn't a whole 1/3 right here. We only have this part. So how many sections, and now I'm going to go ahead and go backwards now on this. So some of the stuff I just drew is going to go away. How many sections, if we're only looking at this right here, just look at those that black box. How many pieces do we have? Well, we have 2, right? So that means we have 1/2 and we have 1/2. So that's why we have 1 and 1/2 of another third. So when we're dividing 1/2 divided by 1/3, we get 1 and 1/2. So the first method is using modeling, what I just showed you here. Let's move on to the second method. The second method is using the algorithm. So when you're using the algorithm, it's going to be just like when we were multiplying whole numbers and, whole numbers and fractions, or dividing whole numbers and fractions, sorry about that. So the first thing that you're going to do is you're going to write your problem. So the problem you have here was 1/2, and actually I'll write it over here in the margins where you guys can see it. So you're going to have 1/2 divided by 1/3. And the first thing that you're going to want to do is you're going to do your keep, flip, change. So you're going to do your keep, flip, change. So you're going to keep the 1/2. You're going to flip the 1/3 and make it 3/1. And you're going to change the division sign to multiplication. Now we're just going to multiply straight across. 1 times 3 is 3. 2 times 1 is 2. Remember, we can't keep it as an improper fraction, so we need to make that a mixed number. 2 goes into 3 one whole time. We have 1 left over, because remember 2 times 1 is 2, so we have 1 left over, and then 2 stays our denominator. So notice we still get the same answer of 1/2 that we got with the model, 1/2. Right there, 1 and 1/2, I apologize, 1 and 1/2. And so we get the exact same answer both ways. Now I realize that modeling takes more time and is more difficult to understand, and that the algorithm is way easier, but the standard calls for you to be able to understand the model. And eventually you're going to have to be able to write your own problem that matches a model. And you're going to have to be able to match models with problems and so on. So you want to make sure that you get your mind around the model. Let's go ahead and try these next three here, these three problems here. So what you want to do now is pause the video. So pause it now, and you want to do these problems here. All right, welcome back. So the first thing you should have done was taken 1/4 and changed this into, instead of being 3/8, now we're going to have 8/3 because that's our flip. And then we're going to change to multiplication. Now, one piece that I told you is absolutely required. You have to cross simplify. So when we look at 3 and 1, there's nothing that we can simplify. If you don't know what I'm talking about, you need to go back and watch video 17 or 18. They're actually the same video twice, so either one would be fine. Now we're going to look at 4 and 8, and we're going to see what can I divide out of both 4 and 8. Well, I can divide 4 out of both 4 and 8. So 4 divided by 4 gives me 1, and 8 divided by 4 gives me 2. And now that I've cross-simplified, I can simply multiply straight across. 1 times 2 is 2, and 1 times 3 is 3. So our answer for A, which we're going to write on the line here, is 2/3. Okay, and as you can see here, I went ahead and did keep, flip, change. We kept the 2/3, we flipped the 3/8 to make it 8/3, and we changed the sign to multiplication. We can't cross-simplify 8 or 3, we can't cross-simplify 2 or 3, so we just have to multiply straight across. 8 times 2 is 16. 3 times 3 is 9. But again, remember, we cannot keep that in an improper fraction. So we have to ask ourselves, how many times does 9 go into 16? Well, 9 goes into 16 one time, and then you have how many left over? Well, 9 times 1 is 9, and then 10, 11, 12, 13, 14, 15, 16. So we have 7 left over. So it should be 1 and 7/9. And you want to be sure to write that over there on the line for B. Now we're going to look at 5/6 divided by 1/3. So now I've gone ahead and set up the problem, 5/6. I flipped the 1/3 and made it 3/1. You want to check to make sure that you did the same. And then we changed the sign from division to multiplication. Now again, we're going to check 5 and 1. There's nothing you can do with 5 and 1. You can't simplify any further. Now we want to look at 3 and 6. Well, I could actually divide 3 out of both of these. So 3 divided by 3 is 1, and 6 divided by 3 is 2. Now I'm going to multiply straight across. 5 times 1 is 5, 2 times 1 is 2. And remember, the last piece is to change this back into a mixed number. 2 goes into 5 two whole times, because 2 times 2 is 4. We have 1 left over from that 5 we originally had as our numerator, and we have 2 on the bottom, because we keep the denominator the same. So if you have problems going back and forth between mixed number and improper fraction, you want to look back at your notes on textbook page 300. Those were the notes entitled MAD. So that tells you how to go back and forth between the two. So you want to go ahead and write your answer right here, 2 and 1/2. So now you should be looking at textbook page 319. So let's go ahead and look at our first problem here, example 2. It says to write a story context for 2/3 divided by 1/6 and use a model to solve. So just on a side note, this is actually a level 4 on our scale. So this is what we're shooting for on our scale, level 4. So let's look and see what they came up with. We want to make sure to annotate our problem as well. It says Mariska has 2/3 a pound of sunflower seeds. Each day, that each is important, she feeds the cardinals in her yard 1/6 of a pound of seeds. For how many days, you want to make sure to underline that, will she be able to feed the cardinals? So the first thing you want to do is make sure that you can get that division problem set up properly, because the most common mistake, the number one mistake you're going to make, is switching the numbers around. So just like I said in class, you want to be looking for has, have, had, is, and started with. So let's go ahead and look at that. All right, so you're looking for those words down here. The whole point of looking for those words is so that you can understand that you're looking to find out what the beginning is that they started with before they started dividing things up. So before they started dividing things up, Mariska had 2/3 of a pound of sunflower seed. Notice that word has. So I know off to the side here that 2/3 is going to be the division problem that I'm going to start with. So I'm going to write 2/3 right here. And then I know that we're going to be dividing, and the reason I know that is because of this word each. Because it says she gave a certain amount out each day. So she gave out 1/6 of a pound each day. So let's go ahead and divide it by that 1/6. Now remember, just like I told you in class, this is what you start with, right? So if your starting amount, this is the size, right? This is the size of the pieces. And then this should be the number of the pieces. So in this case, this is going to be the number of days that she can actually feed the cardinals. So now let's go ahead and do our keep, flip, change, just like we would normally do. 2/3 multiplied by 6/1. Make sure that you check for that cross simplifying, and we see that we can take out the 3 and the 6 here, so we get 1 here and 2 here. And then 2 times 2 is equal to 4. 1 times 1 is 1, and we get a total of 4 days. So our final answer here must actually say 4 days, because we want to refer back to our question and go, what were we solving for? Were we solving for size, so pounds? Were we solving for bags? No, we were solving for how many days. So you want to make sure that your answer includes days, 4 days. So now we're going to look at the model and see if we can make sense of the model. Remember, when we started this section, I said you always needed to start with a whole unit. So even though we're only going to be working with 2/3 of the unit, because that's what we start with, we need to start the model with an entire unit. So that's why this whole bar here actually represents one whole unit. So I'm going to show you. So that's one whole. And I'm saying that for a reason, because that's probably the most common mistake that people make, is not starting with a whole bar. So now I want you to look. You see it right here and right here. What you want to see is that this is a third, this is a third, and that this is a third, right? The reason we broke it into thirds, now don't look at the red lines just yet. The reason we broke it into thirds, remember, was because of that denominator right there. So remember, I told you on that first slide where I said that number on the bottom is what tells you how many slices to cut the whole into. So originally you're going to cut it into thirds. Then you're going to be really looking at 2/3. But before you even think about that, you want to cut the whole unit into sixths. So now I'm going to change to orange so that you can see 1, 2, 3, 4, and 5. So I make 5 marks because that gives me 6 boxes. So as you can see down here, we have got 1, 6, 1, 6, 1, 6, 1, 6, 1, 6, 1, 6. So we have 6, 6 there. But now we need to, before we start doing any counting, we need to actually think about what we're really, really working with. Because remember, you're only working with that whole bar until you look for your answer. So now we're going to go back here and go, oh, okay, we only had 2/3 really to begin with. So this part here, those two don't count, because that's that whole third that we never had, okay? So now we're only going to be looking at the 2/3, and now you can see where they've written 2/3 and they've put a bracket around it right here. So now let's count. We've got 1, 2, 3, and 4. So that represents the 4 days that she can feed the cardinals. I want you to pause the video now, and I want you to try and come up with a story for the equation 3/4 divided by 1/8, and then use a model to solve it. I'll give you my example after you've paused the video and you've done your own. All right, so hopefully you came up with a great problem. This is the problem I came up with. Tommy feeds his dog 1/8 of a pound of dog food each day. He has 3/4 of a pound of food left in the bag. How many days can Tommy feed his dog? So just like usual, we're going to have to first start by finding out what the equation is. So we want to first identify what the has, have, had, or is, or started with is. So it looks like he's starting with 3/4 of a pound because he has 3/4 of a pound of dog food. So notice how it actually started with a different number, but this is the first one in our equation. So we're going to go ahead and write 3/4 down here. And you can write it on line stickies, or you can find a spot on your notebook. Anywhere there is fine in your textbook. So we're going to have 3/4 divided by, the reason we know it's divided by is because of this each day right here. That tells us that it's going to be divided by. And we're going to divide that into pieces that are what size? Oh, the size right there is going to be 1/8 of a pound. So remember, the 3 parts of the division problem are going to be what you start with, the size of the pieces, and the number of pieces. So now we're going to be dividing into 1/8 piece sizes. So now we have our problem, 3/4 divided by 1/8, which is what we had from before. So now we want to use our model to figure this out. Now remember, the first step in our model is going to be to draw a whole unit. So let's go ahead and draw our whole unit right here, just a long bar, and we're going to separate it into fourths. And we're going to do that with those 3 pieces. Now again, you're separating it into fourths because of that 4 right there. Now before we think about only having 3 of those fourths, we need to think about dividing the entire bar into eighths. Well, if we've already divided the bar into fourths, then that means we should be able to split each of our fourths in half, and that should now give us eighths. So now you see 1, 2, 3, 4, 5, 6, 7, 8, correct? Right. So now we have eighths. So now we need to think about how many of these count. So what I mean by that is we're going to go ahead and look and say, okay, remember those fourths that we drew? Those fourths, I'm going to extend the line just a little bit here so you can remember. There's a fourth, there's a fourth, there's a fourth. All right, and then the other one is a fourth. So we're only going to be looking at 3 of those fourths. So just like we did before, we're going to mark out that 1/4 right there. Because see, we have 1/4, 1/4, 1/4, and 1/4. And now all we have left to do is count the number of boxes. So now we have 1, 2, 3, 4, 5, and 6. So that means that Tommy can feed his dog for 6 days. So on your problem, depending on what you used for your story, it's going to be 6 something. So for mine, it was 6 days. So even though I have a question mark there, you want to have the units for whatever your story had in it. All right, this next section is pretty easy. It says to divide a fraction by a whole number. Now this goes back to that level 3. So if you're looking at your scale, it should be on a level 3. Okay, so again, this is a level 3 and it's dividing fractions and whole numbers. So the first thing that they want you to do when you divide a fraction by a whole number is to rewrite the whole number as a fraction. Then you divide as you did with fractions. So this is really pretty simple concept. In this problem here, they rewrote 10 as 10 over 1, and then everything else is the same. You multiply by the reciprocal, that's the same as keep, flip, change. And then, then you want to cross simplify, that's what you're doing right here. So you can add that note right there. And then on that last step, you're just multiplying straight across, and you get 1/14 in this problem. So now I want you to pause the video and you can go ahead and work these 3 problems out now. Since you have little space, I will allow you only for these problems, only for the ones where you just have to change this part into a 4 over 1, I will allow you to do that step right here. So you can go ahead and do 4 over 1, you can do 8 over 1, and you can do 4 over 1. That's okay only for these types of problems. But now you have to work the problem out. So now you have to do the multiplication by the reciprocal, where you're doing 8/9, and then you do multiplied by 1/4. Then you want to cross simplify and so on. So I do expect to see this work right here, but I will allow you to do the over 1 with the original problem, which I never do. So go ahead and pause the video now and do that. All right, so as you can see here, I have the first problem worked out, including the cross simplifying. So we cross simplified the 4 and the 8 to get 1 and 2, and then 2 times 1 is 2, and 9 times 1 is 9. So now I left F and G out like this so that you could see the cross simplifying happening. So now we're multiplying by the reciprocal. We're going to look 5 and 1, that's already simplified, but 4 and 8 you can divide 4 out of. So now I get 1 here because 4 divided by 4 is 1. And I get 2 down here because 8 divided by 4 is 2. Then we're going to multiply straight across. 1 times 1 is 1, and 5 times 2 is 10. So over on your answer line, you need to write 1/10. And then for G, you're going to do the same thing. 13 and 1, you can't simplify any further, but 4 and 12, you can divide 4 out of both of them. So if you started with 2, then you didn't find the greatest common factor. You found a factor, but not the greatest. So 4 divided by 4 is 1, and 12 divided by 4 gives you 3. So now once you've simplified ahead of time, 3 times 1 is 3, and 13 times 1 is 13. So you just made that problem a whole lot easier. And it is required that you're cross-simplifying ahead of time. It is not an option. So you want to check all of your work and make sure it looks exactly the same. All right, guys, we're in the home stretch. Now we're looking here at textbook page 320. Remember, these are the pretty important problems here on this page. You always want to remember that. These are usually the heaviest weighted problems. Those are the 3-point problems on your test. So let's go ahead and look here. Hang on one second. All right, so I'm going to go through this problem with you for example 4. It says Ramon is making party favors. He is dividing. Oh, check that out. They helped you out. They used the word dividing. You should underline that. He is dividing 3/4 pounds of almonds. Ooh, that was a tricky one though. Into 12 packages. Write and solve an equation to find how many pounds of almonds are in each package. How many pounds of almonds are in each package? All right, now I realize it's done for you down here, but I need you to really be able to do it on your own, like in your own brain without seeing it, obviously. So when we look at this problem, this one's a little trickier because they use that word dividing. So what we need to think about, that key question that we always need to think about is what are we starting with? And it is such an important key question that I need you to write it down because as you read all of the word problems, you need to make sure that you're able to identify what you're starting with. So it says he's dividing 3/4 pound of almonds into 12 packages. So remember, he hasn't done the 12 packages yet. So he actually starts with 3/4 of a pound. So that's the first mistake that people are going to make here and the most critical because once you've made this mistake and you put it in the wrong order, you can't come back from that. So let's go ahead and start with the 3/4 of a pound, and we're going to be dividing it into 12 packages. Now I want to just point out that that same thing that I've always told you, this is what we're starting with. So you're going to write start with here. Now check this out. This is the number of packages. Number of packages is the same as like number of pieces. So then what do you think you're solving for? Remember, number of pieces and size of piece are interchangeable, but if you've been given one, then you solve for the other. So we're going to equal, and then what we're solving for will be the size of the package, size of each package. And if you look at your problem, it says, write and solve an equation to find how many pounds of almonds are in each package. So that makes sense. So let's go ahead and start with that 3/4 divided by 12. Now we're going to go ahead and do our multiply by the reciprocal. So we're going to take 3/4 and we're going to multiply it by 1/12. And if you kind of lost me there, it's because we did divide, it's because we changed that 12 into 12 over 1, okay? So then we flipped it and we got 1 over 12. The most important thing you need to do too is make sure you cross simplify. So we're going to divide that 3 out of both of those. So we get 1 here and we get 4 here. And then we're just going to multiply straight across. Now, because I've already made my point about the size of each pack, I'm going to go ahead and erase that so that I have some room for my answer. So now, pardon me, we've got 1 times 1 is 1, and 4 times 4 is 16. So each package is going to have 1/16 of a pound of almonds in it. And that's what they have. Notice they didn't just write 1/16. So you want to make sure that you're able to identify each of the 3 pieces of your division of fraction problems. All right, yay, you made it. You can pat yourself on the back. We're at the end of this video now. So what you're going to want to do is do numbers 1 through 5. You're going to want to do those now. And I do want you to be thinking about question number 6 because when you come in, I'm going to have you post to a discussion board on Canvas. So definitely be thinking about 6, but I want you to do 1 through 5. And also, super duper important, I want you to go ahead and rate yourself. We've been talking about scales. We've been working with scales. I want you to go ahead and rate yourself and tell me where you think you are based on this concept. So good luck, and I will see you in class tomorrow. Thanks for tuning in.